Good afternoon, Science 30. I'm going to continue lesson today looking at quantifying the pH scale. We're going to learn how to calculate pH and pOH and determine pH qualitatively. I'm also going to do a titration and finish up the acid-base section of this unit. So if you look at your slides, there's this slide calculating pH. These are your equations. Right, pH equals the negative log of H3O plus. This gives you a little definition and some guidance as to how to calculate pH. Now remember that the pH scale is logarithmic, so it uses log, so it increases by an equal exponential factor each time we change. So a change of 6 to 7 on the pH scale is a factor of 10. A change from 6 to 7 to 8 is 2 factors of 10. So going from a pH of 6 to 8, increasing on the pH scale, that would be 100 times more basic. And decreasing levels on the pH scale is increasing scale of acidity. So each time we transfer from one level of pH, that's an increase by a factor of 10. So logs, what they do is provide linear relationships for exponential relationships. Okay, so we can use two different equations to solve for pH and pOH and concentration. So if I go back to slide here, I can solve for the power of hydronium. pH equals the negative log of H3O plus, and likewise the concentration of H3O plus equals 10 to the negative pH. Okay, so for example for that, I give you an example question here. A solution has a pH of 3.4. What is the concentration of hydronium ions? And you can see that we always measure in moles per liter. So 10 to the negative 3.4 when we use our exponents on a calculator equals 3.98 times 10 to the negative 4th moles per liter of hydronium. So there's explanation for this on how to use your calculator on page 181 in your textbook. There's also a pH scale in your textbook on page 180 that you should absolutely take a look at. And using logs and exponent values are given to you in your Science 30 booklet. Right, calculating pH as well. Okay, so make sure you take a look at those things. We'll look at the pH scale qualitatively as well, but there's some relationships that you need to understand about pH and pOH. Just give me a second here. Okay, so the acid ionization constant of water is actually 1.0 times 10 to the negative 14th moles per liter, and that's where we get this relationship, pH plus pOH equals 14. So I can actually transfer between pH and pOH by solving for one of the two. So pOH is the power of hydroxide, which is base acidity, and pH is the power of hydronium, which is acidity. Okay, so all relationships that we need to understand. So I'm going to do a couple textbook questions for you. And this is page 183, 22, 23. And there's more practice questions at the end of this unit for you. So let's look at some of these questions here. So page 183. Number 22 says, for each hydronium ion concentration, calculate the pH. And again, pH equals the negative log of the concentration of hydronium. Okay. So, this is number 22. Okay, and A is 0.001 moles per liter. Okay, mole per liter H3O plus. Just need to grab a calculator here. So let's walk through what we need to do with this calculator. So pH equals the negative log of 0.001 moles per liter. Okay, so let's solve for that. All right, so what have I got? I have the negative log of 0.001 moles per liter. So my pH, okay, so my pH is 3. Okay, let's look at B. B says 2.0 times 10 to the negative 4. Okay, 2.0 times 10 to the negative 4 moles per liter. So calculate the pH. That is the negative log of 0.0002. Okay, 1, 2, 3, 4. That's how many times I move the decimal place over in order to get my negative exponent. So my negative log is 0.0002. Okay. And you can see that I get about 3.69. All right, so pH of 3.69. Okay, so let's use a different strategy with the next question here. So you have A, B, C, D, and E, and I'm going to do E here. So E is, I have 1.54 times 10 to the negative 12 moles per liter of H3O plus. Okay, so pH is going to equal the negative log of 1.54 times 10 to the negative 12. So that's it's going to be probably a relatively high pH because that is a very dilute concentration of hydronium. Okay, so when I plug this into the calculator, here's what this looks like. Negative log, okay, and then I'm going to put in 1.54. Second function, e to the e. Okay, so my e to the e button, which is right here, like press second function first, and then negative 12. Okay, and so it should look like that. A lot of you have calculator issues, and you know how to do the problem, you just don't know how to use your calculator properly. So use that as a little tutorial. And that should equal about 11.81. And you can see that because this is a dilute concentration of hydronium, the pH is very high. So this is quite basic. Okay, so that is how we solve for pH. Okay. let's look at page 183 again, and this is going to be number 23. We're going to solve for the hydronium ion concentration rather than the pH. So they're giving you the pH here. So so the pH equals 7. All right, so concentration of H3O plus is going to equal 10 to the negative 7.0. Okay. And when we solve for that, 10, second function, e to the e, negative 7. Oh, sorry, that's not correct. 10. Use the exponent triangle here, and that will be 1.0. Okay, 1.0 times 10 to the negative 7. That's what that stands for. 1.0 times 10 to the negative 7 moles per liter. Okay. B, let's look at this one, 2.98. pH is going to equal 10 to the negative pH, and that equals 10 to the negative 2.98. So here's how we do this. 10 exponent, so use this, okay, negative 2.98. What do we come up with? 0.001. Okay, so this is hydronium ion concentration. Okay, and that is how you solve quantitatively for pH. So those practice questions are on page 183. I'm going to give you one word problem style question here. Okay, so let's say we have this. Let's say in a basic solution, okay, the concentration, so brackets means concentration. So the concentration of hydronium, which remember is acidity, okay, is 3.0 times 10 to the negative 9 moles per liter. Okay. Calculate the pH, the pOH, and the hydroxide ion concentration in this solution of NaOH, or sodium hydroxide. So this is a basic solution. You'll have a low concentration of hydronium. So they actually give you the values of acidity and then want you to find the values for basicidity. So we have to use that pH-pOH relationship. So the first thing we're going to do, we have the concentration of hydronium. So I'm going to write down what I have. I know that I have this. So this is 3.0 times 10 to the negative 9 moles per liter. Okay, so what can I do with this? I can solve for pH, right? So I know that pH equals the negative log of the concentration of hydronium. Okay, so if I look at this, it's asking me to solve for pH, solve for pOH, and then solve for the concentration of hydroxide. So my A is pH. pH equals the negative log of hydronium, and that is going to equal negative log of 3.0 times 10 to the negative 9. Okay, so let's plug that into the calculator. Negative log, and I'm going to use 3.0 e to the e negative 9. Okay. And what do we get? We get a pH of 8.52. Okay, so pH equals 8.52. So we have a basic solution, slightly basic. Okay, now the other one asks you to solve for, the next question asks you to solve for pOH. So I know that pH plus pOH equals 14. Okay, so what I do is just plug this in. So 8.52 plus pOH equals 14. And so 14 minus 8.52 equals pOH. Okay, 14 minus 8.52 is 5.48. So there is a corresponding pOH scale which acts the same way as pH, but we usually just use the pH scale because generally humans are more interested in acids and bases because we have more products that we come into contact with that are acidic. All right, but it works exactly the same way. You just don't usually see the pOH scale in common language. But anyway, we have the pOH, and we can solve for the concentration of hydroxide. And we solve for the concentration of hydroxide the same way we'd solve for the concentration of hydronium. So the concentration of hydroxide equals 10 to the negative pOH. Okay? And that is 10 to the negative 5.48. So 10. All right, use your little Christmas tree here. To the negative 5.48. My concentration of hydronium equals 3.3 times 10 to the negative 6. .3 times 10 to the negative 6 moles per liter. Okay, so that's how we solve for pH and pOH. You're probably not going to see pOH, but it is fair game for Science 30. So that's the first way that we solve for concentration of acidity and basicity quantitatively. So this is what we would use in any sort of ecological practice to understand if acidity due to acid precipitation was happening in an environment. All right, so I'm going to ixnay this video right now, and I'm going to do 2 other smaller videos on measuring pH quantitatively and then looking at a titration as well, which is a quantitative measure, and we're going to look at measuring pH qualitatively using pH indicators too. Okay, so this will be posted on YouTube and come back for the other few videos. That'll be the last of this first section of the unit on acid-base chemistry and environmental chemistry. Okay, so if you have any questions, page me on D2L, and we will chat soon.